Welcome back to QHSE Talks. Hazardous materials management is often misunderstood because it's framed as a handling issue instead of a control system. People think in terms of containers, labels, storage rooms, and procedures. Professional safety practice sees something else entirely: governance structures, regulatory architecture, operational dependencies, and liability pathways that define how risk actually moves through an organization. This isn't a storage problem, it's a system control problem. The moment a substance enters an operation, it becomes part of a managed life cycle. Classification rules activate, compatibility limits apply, transportation law engages, environmental accountability attaches, emergency planning obligations emerge, worker exposure risk is defined, disposal responsibility is assigned. None of this exists in isolation, and none of it is optional. Every transfer changes risk distribution. Every inventory shift alters exposure. Every container carries obligation. That continuity is what makes hazardous materials management uniquely complex. And that's why this chapter matters so much from a CSP 11 perspective. From an environmental management lens, Domain 5, this is about lifecycle control, waste governance, remediation responsibility, and environmental protection systems. From an emergency management lens, Domain 4, this is about spill response structure, uncontrolled release planning, site control, and emergency preparedness. From an occupational health and applied science lens, Domain 6, this is about applied chemistry, physical properties, exposure pathways, corrosion, pressure dynamics, and scientific control of risk conditions. This chapter doesn't sit in one domain, it integrates domains. It connects science to governance. It connects regulation to operations. It connects emergency systems to environmental protection. It connects worker safety to public safety. One breakdown does not stay local. It propagates through environmental damage, regulatory enforcement, financial exposure, operational disruption, workforce harm, and public trust at the same time. So this chapter isn't about learning substances. It's about understanding systems. It's about life cycle risk. It's about control architecture. It's about management discipline. Because professional safety at this level isn't produced by memorization, it's produced by structure, logic, and continuous control. And that's the lens we're using for this episode.
The goal here is to give you the why behind the what. Because look, memorizing tables is one thing.
Right.
But understanding the liability and the physics behind it all, that's what actually keeps people safe.
Let's start right at the foundation then. Section 1 of our outline covers the sheer struggle of management. The source material makes a really interesting point right off the bat. It says the job is hard not just because the chemicals are dangerous, but because of the almost continuous hazardous materials inventory.
And that is the core challenge.
Yeah.
It really is. Think about most safety hazards for a second. A fall hazard is static. A hole in the floor is a hole in the floor until you patch it. A noisy machine is, well, it's always noisy. You can put a control in place and, for the most part, walk away.
But chemicals move.
Chemicals flow,
Yeah.
literally and figuratively. You have raw materials arriving, that's your inventory. You use them in a process, that's production. You create byproducts, that's waste. And then you ship that waste out.
So the actual chemical makeup of your building changes hour by hour.
Constantly. It's a moving target. You might be perfectly compliant on Tuesday morning. You are below all the important thresholds. You're safe.
And then what?
Then Tuesday afternoon, a shipment arrives or a production run finishes, and suddenly you have crossed a line. You are now in a completely different regulatory bracket.
And nobody rings a bell to tell you that you've crossed it.
No bell. Not at all. Just the silent accumulation of liability. That is why Yates put so much emphasis on control of incoming hazardous materials.
The front door.
Exactly. If you don't control the front door, you have already lost the battle inside the warehouse.
Speaking of losing the battle, let's talk about the ghost that really haunts this entire chapter. The legal backbone. SUCLA.
The Comprehensive Environmental Response, Compensation, and Liability Act, passed back in 1980.
Most people know it by its nickname, Superfund, which frankly sounds like a lottery you win. Hey, I won the Superfund.
It is the exact opposite of that. If you are involved with a Superfund site, you have definitely lost the lottery. This act was really a response to the environmental disasters of the 1970s.
Like Love Canal.
Places like Love Canal, exactly, where companies just buried toxic sludge, covered it with some dirt, sold the land, and just walked away.
And then 10 years later, houses are built, schools are built, and people start getting sick.
Precisely. So Congress stepped in and basically said the party is over. Yates outlines 3 main pillars of CERCLA in the text.
Let's walk through them, because this really sets the stakes for everything else we're going to talk about. So pillar 1.
Prohibitions and requirements. This basically just says you can't dump things anymore. It sets all the rules for dealing with closed and abandoned sites.
Okay, so that's the don't be an obvious villain rule? Fair enough. Pillar 2.
Liability. This is the teeth of the act. This is the part that keeps safety managers and, frankly, CEOs up at night. CERCLA establishes liability for persons responsible for releases at these sites. And this is where it introduces the concept of cradle to grave.
Cradle to grave. It sounds so dramatic, almost biblical. But practically speaking, what does that actually mean for me, the guy with the drums on the loading dock?
It means that you are married to your waste until death do you part. And even then, your estate might still be liable.
That seems extreme. Let's play this out. I generate a barrel of toxic solvent. That's the cradle.
Right.
I pay a licensed, reputable trucking company, let's call them Safe Haul Incorporated, to take it away. They take it to a licensed, state-of-the-art landfill. I have the receipt. I paid them. Isn't it their problem now?
You would think so. It seems logical, but under CERCLA, no. You generated it. You created the hazard. So if Safe Haul Inc. spills it on the highway,
I'm involved.
You are involved. If that landfill liner cracks 30 years from now and poisons the local groundwater, and the landfill company has since gone bankrupt, the EPA comes back to you.
Even though I followed all the rules at the time, I did my due diligence, I hired a good company.
Yes. That's the part that people find so shocking. It is retroactive, strict, joint, and several liability. They can come after anyone in that chain who has money.
So I can outsource the labor of moving the waste, but I cannot outsource the liability.
You can never, ever outsource the liability. That sticks to you like glue. And that is why hazardous materials management isn't just about keeping the floor clean. It's about the financial survival of the company.
You have to know exactly where that stuff is going.
Because if it ends up in a roadside ditch somewhere, your company's name is on the lawsuit.
Okay, so what's the third pillar?
The trust fund. That is the actual super fund. It was basically a big pot of money established to clean up orphan sites where they couldn't find anyone to sue.
But if they can find you...
Oh, they won't touch the trust fund. They will use your bank account.
Okay, I'm sufficiently terrified. The stakes are established. Infinite liability. Let's move from the legal theory to the operational reality. We are in the facility. We are making waste. The EPA doesn't just treat everyone the same, do they? They have a scoreboard.
They absolutely do. And this brings us to Section 2, the numbers game. This is all about the EPA generator categories. And this is vital for the CSP exam and just for your day-to-day job.
So how does it work?
The EPA classifies you based strictly on how much waste you generate in a single calendar month.
And Yates provides a great breakdown in Table 27.1. There are 3 tiers. Let's start at the top. The heavyweight division, the large quantity generator, or LQG.
An LQG is a facility that generates greater than or equal to 1,000 kilograms of hazardous waste per month.
1,000 kilograms, that's what? About 2,200 pounds? To the average person listening, that sounds like a massive amount of trash.
It sounds like a lot. But in an industrial setting, it's surprisingly easy to hit that number. Think about a standard 55-gallon drum.
Okay.
Filled with some kind of liquid. That drum can weigh anywhere from 400 to 500 pounds, just depending on the density of the liquid inside.
So do the math. That's only 4 or 5 drums in a whole month.
That's it. 4 or 5 drums. If you are a manufacturing plant or a painting operation or even a large print shop, 4 drums could be a really light month.
And if you hit that 1,000 kilogram mark, what happens? What changes?
Well, the handcuffs go on, basically. You're an LQG. You suddenly have these strict 90-day storage limits. You have to get that waste out fast.
90 days.
You have extensive contingency planning requirements. You have biannual reporting you have to do to the government. It is a very heavy administrative burden.
But here is the gotcha that I found in the text, and this is where the safety professional part really kicks in. You can become an LQG without generating 1,000 kilograms.
Ah, yes. The acute waste trap. This is probably the most dangerous pitfall in all of these regulations.
The text says, and I'm quoting here, Greater than 1 kilogram of acute hazardous waste.
1 kilogram. That's 2.2 pounds.
That's a jar of peanut butter. That's a tub of protein powder from the gym.
Exactly. Imagine you run a small lab. You generate almost no waste, maybe a few pounds a month, but you have one specific project that uses a cyanide compound or a specific pesticide that is on the EPA's P list of acute toxins.
So the really nasty stuff.
The really nasty stuff. You spill 1 quart of it, or maybe you just decide to dispose of an old container that weighs 3 pounds.
And suddenly,
for that calendar month, you are an LQG. You are regulated in exactly the same way as a massive oil refinery.
that feels incredibly disproportionate. How can 2,200 pounds of, say, used solvent put you in the same bucket as just 2.2 pounds of this acute stuff?
It does feel that way, but it highlights the EPA's philosophy here. They aren't just looking at volume, they are looking at lethality. Acute wastes are so incredibly dangerous that the threshold for strict regulation is basically 0.
So for you listening, the big takeaway is check your inventory for anything listed as acute waste, because that is the tripwire.
Absolutely. You can sleepwalk right into LQG status if you aren't watching that 1 kilogram limit like a hawk.
Okay, let's look at the other tiers quickly, the middle ground.
That would be the small quantity generator, or SQG. The threshold here is greater than 100 kilograms, but less than 1,000 kilograms.
So roughly half a drum up to those 4 or 5 drums.
Right. And importantly, for acute waste, you must stay at or below that 1 kilogram limit. If you cross 1 kilogram of acute, you are an LQG, period. Doesn't matter what your other waste total is.
And the bottom tier, the one everyone wants to be in.
The conditionally exempt small quantity generator, or CESQG. You might see it as very small quantity generator, VSQG, in newer docs, but Yates uses CESQG.
And the limit for that?
Less than or equal to 100 kilograms per month.
That's about 220 pounds, maybe half a drum's worth.
Correct. And again, you have to stay under that 1 kilogram of acute waste.
I noticed the word conditionally is doing a lot of heavy lifting in that name.
It is. It's the most important word. You are only exempt if you meet the conditions. It's not a permanent status. It is a monthly test. If you have a big spring cleaning day and you toss out 150 kilograms of old paint,
You blew it.
you blew it. For that month, you are an SQG. You now need an EPA ID number. You need to follow all the SQG storage rules. You can't just say, oh, but usually we are really small.
Right.
The EPA does not care about usually. They only care about the calendar month.
This circles right back to that continuous inventory problem we started with. You have to be counting the pounds constantly. It's a numbers game, and if you get the math wrong, you're non-compliant.
Precisely. It's constant vigilance.
Okay, so we have weighed the waste, we have labeled it, we know if we are an SQG or an LQG, but we can't keep it in the warehouse forever. Eventually, that truck from Safe Haul Inc. backs up to the dock.
Right.
And the moment that forklift crosses the threshold from your dock onto the trailer, the entire world changes.
It does. The EPA rules don't disappear, not entirely, but they definitely take a back seat. And the Department of Transportation, the DOT, takes the wheel.
And their priorities are totally different.
Completely different. The EPA asks, how much did you make this month? The DOT asks, if this truck crashes into a minivan on the interstate, what is going to happen and how do we keep the first responders alive?
And to answer that question, we have the DOT hazard classes. Yates details these in Table 27.2. There are 9 main classes. And I want to dig into these because this is where the deep dive gets really interesting. It's not just a list. It's a tactical guide for survival.
It really is. Let's start with Class 1, explosives.
Most people hear explosives and just think, boom, but the DOT breaks it down into 6 different divisions. Why all the granularity?
Because not all booms are created equal. The division tells the firefighter how far to run.
Let's look at Division 1.1 then. This is the big one, the really scary word.
Division 1.1 is a mass explosion hazard.
Define mass explosion for me.
It means that if one stick of dynamite in the truck goes off, the entire truckload goes off almost instantaneously. The shock wave propagates through the whole load at once.
So we are talking about a crater.
We're talking about a crater. We're talking about leveling a city block. If a firefighter sees an orange placard with a 1.1 on it, they are not grabbing a hose.
No.
They're grabbing the radio and ordering an evacuation of a 1-mile radius, maybe more.
Now contrast that with Division 1.4.
Division 1.4 is a minor explosion hazard. The effects are largely confined to the package itself. This is stuff like consumer fireworks, road flares, or small arms ammunition.
So bullets.
Right. If a box of ammunition catches fire, the bullets will pop, 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 pop. but they don't detonate with a shockwave that takes out the whole truck.
So a firefighter can actually approach that.
A firefighter can actually approach a burning truck with 1.4 materials. They can fight that fire. The difference between the number 1.1 and 1.4 on a placard isn't just paperwork.
It's the difference between fight the fire and run for your life.
Literally. That is why misclassifying explosives is such a huge crime. You are lying to the emergency responders about their own survival odds.
What about 1.5 and 1.6? These sound like oxymorons. Very insensitive explosives.
Yeah, it does sound a little funny. Division 1.5 is very insensitive explosives with a mass explosion hazard. Think of something like blasting agents used in mining. They are really, really stable.
Hard to set off.
Very hard. You can drop them, shake them, maybe even shoot it with a rifle and they won't go off. They're hard to initiate.
But there's a but.
But if you do manage to set them off, maybe with a proper detonator and a booster charge, they go off just like a 1.1. They mass detonate. Big boom, just hard to start.
Okay, and 1.6.
Extremely insensitive articles, no mass explosion hazard. These are the safest of the explosives, very hard to light, and no crater if they do light.
Let's move to class 2, gases. Again, we see this breakdown based on what the gas does to you, not just that it's a gas.
Exactly. Gas is just a state of matter. The DOT wants to know the specific hazard. So Division 2.1 is flammable gas.
Propane, hydrogen.
Propane, hydrogen, methane. The placard is red. Red means fire. If it leaks and finds an ignition source, you have a fireball.
Division 2.2.
Non-flammable, non-poisonous compressed gas.
Yeah.
Things like helium, nitrogen, argon. The placard is green. Green usually means go or safe, but here it just means not flammable, not toxic.
But it's not perfectly safe, right?
Oh no. It's under extremely high pressure. If the valve snaps off, that cylinder becomes a missile. And if it leaks and fills a room, it displaces all the oxygen. You can suffocate, but it won't burn you or poison you chemically.
And then there's Division 2.3, the one with the skull and crossbones on the placard.
Poison gas
Uh-huh.
or toxic gas. Chlorine, phosgene, it's a white placard. This is the invisible killer. A leak here isn't a fire, it's a toxic cloud drifting downwind.
So if you see a truck with a skull placard overturned,
You don't look for smoke. You look for the wind direction and you run the other way, uphill and upwind.
it's amazing how much critical information is packed into just a colored diamond with a number on it.
That is the genius of the entire system. It transcends language. Red is fire. Skull is death. You don't need to read English to know you should stay far away.
Now let's get into section 4, the chemistry of transport. We are talking about liquids. And I want to pause here because there is a specific number in this section that I feel like is the holy grail for anyone taking the CSP exam.
It is the single most important number in all of Class 3. You have to know it.
141 degrees Fahrenheit.
141. Or 60.5 degrees Celsius, if you're using that.
Why is this one number so important? What makes it the chosen one?
Because it is the line in the sand. It is the dividing line between a flammable liquid and a combustible liquid.
Okay, let's unpack that distinction, because to a layman, flammable and combustible sound like synonyms. They both just mean it burns.
In the dictionary, sure. But in the DOT regulations, they are totally different worlds with different rules. A flammable liquid has a flash point of 141 degrees Fahrenheit or less.
And a combustible.
A combustible liquid has a flash point above 141 degrees, but less than 200 degrees Fahrenheit.
Let's define flash point quickly for anyone who might not be familiar.
Right. Flash point is the lowest temperature at which a liquid gives off enough vapor to form an ignitable mixture with the air. So basically, how hot does a liquid have to get before a match will make it flash?
So let's use a real-world example. Gasoline.
Gasoline has a flash point of about negative 45 degrees Fahrenheit.
Negative 45.
Right. So even if you are in Antarctica in the middle of winter, gasoline is giving off enough vapor to explode. It is always ready to ignite. That is way below 141 degrees. So gasoline is a flammable liquid.
Now, what about something like diesel fuel?
Diesel usually has a flash point somewhere between 125 degrees and maybe 160. It sits right on that border, depending on the blend. But let's take something like a heavy fuel oil or a lube oil. It might have a flash point of 150 degrees Fahrenheit.
So if I have a bucket of that oil in this room, which is, say, 70 degrees,
It is not giving off enough vapors to ignite. You could literally drop a lit match into that bucket of oil, and the match would probably just go out, sizzle and go out.
you have to heat it up first.
You have to heat the oil up to 150 degrees before it becomes dangerous. That is a combustible liquid.
So for the DOT, flammable is dangerous now. Combustible is dangerous if heated.
That's a perfect way to put it. And that distinction changes the packaging requirements, the placarding, the handling rules. If you are taking the exam and you see a liquid with a flash point of 142 degrees Fahrenheit, do not call it flammable.
You will get the question wrong.
You will get it wrong every time.
Oh.
It is combustible.
141 is the magic number. Got it. Now let's move to class 4, solids. This is where the chemistry gets a little weird. We tend to think of solids as being inert. You know, a block of wood doesn't just spontaneously attack you.
But class 4 solids do. These are what I call active solid. Division 4.1 is flammable solid. Simple enough, like magnesium strips or safety matches. They burn easily and vigorously once ignited.
Okay, then 4.2.
Division 4.2 is spontaneously combustible.
Spontaneously. That is never a word you want to hear in a safety context.
No, it's not. These are pyrophoric materials. They can ignite just by coming into contact with air. You don't need a match. You don't need a spark. You just open the lid of the container, oxygen hits it, and 5 minutes later you have a fire. White phosphorus is the classic example here.
But Division 4.3, This is the one I really want to spend some time on. Dangerous when wet.
This is the great paradox of safety.
We spend our whole lives being taught fire equals bad, water equals good. If there is a fire, you spray water on it.
Right. It's the universal instinct. It's what every movie teaches you.
But Division 4.3 materials, things like sodium metal, potassium, calcium carbide, they react violently with water.
Extremely violently. If you throw a chunk of pure sodium in water, it fizzes, generates an incredible amount of heat, and releases hydrogen gas. And of course, hydrogen gas is itself explosive.
So let's paint a picture for the listener. A truck carrying Division 4.3 sodium metal crashes on the highway. It's a rainy day.
The rain is literally acting as an accelerant. The water is reacting with the sodium, creating hydrogen gas, and the heat from that reaction ignites the hydrogen. The truck is essentially exploding because it is wet.
Now imagine the fire department shows up, they see smoke and flames, they unroll the hoses.
If they don't see that blue placard, the dangerous when wet placard, and they spray water on that truck, they aren't putting out the fire, they are pouring gasoline on it.
It's a recipe for disaster.
They are likely going to cause a massive explosion that could kill them.
It really emphasizes that you cannot just operate on autopilot. You can't just follow the standard procedure of spraying water without checking the class.
You have to respect the chemistry. The fundamental laws of the universe don't change just because you want to put a fire out. If the chemistry says water makes me explode, then water makes it explode.
We'll come back to that idea in the outro because it has huge implications for warehousing and storage. But let's finish the list with Class 5. Oxidizers.
Class 5.1 oxidizers. These are the enablers of the fire world. They're the bad influence.
So they don't burn themselves.
Not necessarily, but they yield oxygen. Fire needs 3 things, right? The fire triangle: fuel, heat, and oxygen. Usually a fire is limited by how much oxygen it can suck out of the surrounding air.
But if you add an oxidizer,
It's like injecting nitrous oxide into a race car engine. You are providing pure, concentrated oxygen directly to the reaction. The fire burns hotter, brighter, and way, way faster.
and it makes it harder to put out.
Crucially, yes. It is very hard to smother. You can't just put a blanket over it or use a CO2 extinguisher because the oxygen isn't coming from the air. It's coming from inside the chemical reaction.
So storing oxidizers next to flammables is a terrible idea.
It is the worst idea. You are storing the fuel right next to the turbocharger. If a fire starts, you don't just have a fire, you have an inferno.
This brings us perfectly to our last big section, integration. The voluminous nature of the job, as Yates puts it. We have talked about the EPA numbers, we've talked about the DOT classes, but the safety professional doesn't get to choose one or the other.
No. You have to wear the 2 hats all the time.
Let's role play this. I want you, the listener, to visualize this. You are standing in front of a 55-gallon drum in your warehouse.
Okay. First, you put on your EPA hat. You're looking at that drum and you're asking, is this waste? How much does it weigh? Does this weight push my monthly total over 1,000 kilograms? Is it an acute waste? Do I need to report this on my biennial report?
You're thinking about quantity and time.
Exactly. Quantity and time.
Okay, check. I've done the math. I'm in SQG this month. I'm good. Now I'm shipping it out. I take off the EPA hat and I put on the DOT hat.
And now your questions change completely. You don't care how much you made this month anymore. You care about the physics. You're asking, what is the flash point of this liquid? Is it below 141 degrees? Okay, it's flammable. I need a red label. I need a UN number. Is it compatible with the other drums going on the truck? Can I put this oxidizer next to that flammable?
No.
No, you were thinking about hazard and transport.
And if you get the EPA part right but the DOT part wrong?
The truck gets stopped by a state trooper during a roadside inspection. They look at the placards. They see a mismatch between the placard and the shipping papers. you get a hefty fine.
Right.
Or worse, there is an accident, and the first responders use the wrong tactic because you mislabeled it.
And if you get the DOT part right, but the EPA part wrong,
Then the EPA inspector shows up for an audit, they go through your records, they see you generated 1,200 kilograms of waste last March, but you're acting like a small quantity generator, you didn't file the right reports, you stored it too long, you get fined.
it is a constant tightrope walk. And bring it back to the very beginning of Chapter 27, this is why that continuous inventory problem is so stressful.
Right, because every single time a new shipment arrives, or a waste drum is filled, the puzzle pieces all move. If the purchasing department buys a pallet of magnesium, that's a class 4.1 flammable solid, you have to know where to put it.
You can't just stick it anywhere.
You can't put it next to the oxidizers. You can't put it under the wrong type of fire sprinklers.
The safety manager is effectively the gatekeeper. You are the one standing between the chaotic flow of commerce and the rigid, unforgiving laws of physics and government.
It is a massive responsibility. You have to have a system. You can't keep all this in your head. You need a way to track the inventory, track the weights, and flag the hazards before they even enter the building.
So let's wrap this deep dive up. We have covered a massive amount of ground here. Let's do a quick recap of the biggest takeaways.
Sure. I think there are 3 big ones. Takeaway 1. CERCLA, it's all about liability. Cradle to grave. You can never, ever get rid of your responsibility for hazardous waste.
Takeaway 2.
EPA generator status. It is a pure numbers game based on calendar months. 1,000 kilograms is the line for large quantity. And you have to watch out for that 1 kilogram trap for acute waste.
And the third?
DOT classes. They define the physical hazard for transport. Remember the difference between 1.1, mass explosion, and 1.4, minor. And of course, remember the magic number. 141 degrees Fahrenheit for flammable versus combustible liquids.
I want to leave the listener with a final provocative thought. We talked about class 4.3, dangerous when wet.
Yes, this is something I want every safety manager listening to this to check tomorrow morning at their facility.
Most warehouses, especially modern ones, have sprinkler systems. They're the default safety code requirement for fire protection.
Correct. Standard water sprinklers.
But if you are storing class 4.3 materials, sodium, magnesium, calcium carbide, and you store them on a rack under a standard everyday water sprinkler head,
You haven't designed a safety system. You've designed a catastrophe. You've built a bomb. If a small trash can fire starts, and it's just hot enough to set off that sprinkler,
the water hits the class 4.3 material.
and the building explodes,
The very thing designed to save the building becomes the weapon that destroys it.
it happens. And it happens because someone checked a box for sprinklers on a form, but they didn't read the chapter on hazardous materials management.
That is the perfect summary of why Chapter 27 matters so much. These rules aren't there just to uncle you. They are there to describe reality. And if you ignore the rules, you are ignoring reality. And reality has a nasty way of catching up with you.
Usually on a Friday afternoon.
Exactly. Thank you so much for joining us on this deep dive. Go check your flashpoints, go weigh your acute waste, and we will see you on the next one.
Stay safe out there.